Dear students, in this video we will discuss one of the physical property of water, that is specific heat, or we can also say specific heat capacity. Just like boiling point, freezing point and density, specific heat or specific heat capacity is one of the physical property of a pure substance which is a fixed amount and is not same with any other pure substance. Specific heat capacity of water is very high. But before discussing that, let's discuss what is specific heat capacity. Specific, like you know what is boiling point, you know what is freezing point, but you might not be knowing what is specific heat. A specific heat capacity of any substance is equivalent to amount of heat required to raise, means increase temperature of unit mass of that substance by 1 degree Celsius. You already know that when heat is provided to a substance, then temperature increases. If heat is taken away from the substance, then temperature decreases. But the amount of heat needed by different substances, unit mass, to increase the same 1 degree Celsius temperature is not same, it is different. It means specific heat capacity of different pure substances is different. For water, it is 1 calorie, short form of calorie, CALORY is CAL, calorie per gram per degree Celsius. If we don't want to take gram as the unit of mass, then it will be 1000 calorie per kilogram per degree Celsius. It means if the 1 gram of water is provided 1 calorie of heat, then its temperature will increase by 1 degree Celsius. Or for 1 kilogram of water, that is 1000 gram of water, when 1000 calorie heat is absorbed by it, then its temperature increase by 1 degree Celsius. So per gram of water absorbs 1 calorie heat to increase its temperature by 1 degree Celsius. Same will be about decreasing of temperature. If 1 calorie of heat is taken away from 1 gram of water, then its temperature will decrease by 1 degree Celsius. By this you can always calculate amount of heat required to raise temperature of a particular weight of water. Suppose 100 gram of water is there and you want to increase its temperature from 70 to 75 degrees Celsius, means 5 degrees Celsius. Then how much heat is to be provided to it? First 100 gram, so 100 calorie for 1 gram, and if 5 for 1 degree Celsius. So for 5 degrees Celsius, how much it will be needed? 500 calories. 500 calories heat if provided to 100 gram of water, then its temperature will increase by 5 degrees Celsius. Children, this amount seems to be very small, only 1 calorie per gram, but that is not the fact. Actually, specific heat capacity of water is very high in comparison to other pure substances. And due to this property of water, it is used as a very good cooling and also heating substance. Cooling substance like in coolers, like in machinery part, like for cooling of anything, we need normally water. Not just because water is present in plenty, but also because its specific heat capacity is very high. So it absorbs a lot of heat from the substance and yet its temperature does not increase too much. So high specific heat capacity makes water a good coolant as well as a good heating of substance. For example, in hot water bottles, we use water only because the hot water that we use in hot water bottles, it doesn't get cooled so quickly. Simply you understand that if water is heated, if water is hot, it does not get cooled so quickly, and if it is cooled, then it does not get heated very quickly. As a result, water becomes a very suitable substance. In car radiators as well, we use water. So machine parts or the air coolers, in all these things water is used as a coolant because of its high specific heat capacity, that is 1 calorie per gram per degree Celsius. And for the same reason it is very in atomic reactors as well, a lot of heat is produced in atomic reactor, and for absorbing that heat we use water. You know, steam engines work on this principle only, that heat of burning of the fuel is absorbed by water, then that water get converted to steam, and that steam is used to run the train or other steam engines. So water is very suitable to be used as a heating agent as well as a cooling agent due to its high specific heat capacity.